There are two exercises in this module. I'm going to describe them both to you now, and then I suggest that you take some time and go away and try and solve them by yourself. If you succeed or fail, come back and I'll work through the solutions that I provided for you. The first exercise: write a program that asks the user two separate questions. Their first name and their last name. I want that to be two separate scanfs. Then, when both names are read in, I want the program to join them together. Produce the user's full name. Make sure you put a space between their names. Output the total name, and also output the length of that name, the number of characters in their name, including the space. Okay. The second program is a program to convert Celsius to Fahrenheit. I want the user to type in a Celsius temperature in degrees, and I want the program to convert that into Fahrenheit and then output the result to 2 decimal places. If you don't know what the formula for converting Celsius to Fahrenheit, it's 32 plus the degrees Celsius times 9/5. So for example, if the degrees Celsius were 100, then 100 times 9/5 is 180, plus 32 is 212. So 100 degrees Celsius is 212 degrees Fahrenheit. Now, I want the result to be to 2 decimal places. I know I said that before. There's two ways of achieving that. There's an easy way, and then there's a not so easy way. And I'll give you a hint. I'll give you the easy way of doing it, and then I'll describe a little bit about the hard way of doing it. The easy way to do it is to get the user to read in the Celsius degrees into a double. In other words, wherever you store the Celsius in your program, store that in a variable that is of type double. So that should make the program quite easy for you. If you want a challenge, if you want the difficult way of doing it, then the variable that contains the Celsius degrees, make that an integer. Read in the number as an integer and see if you can get the result to come out to 2 decimal places. You might think that's easy, but it actually requires you to do something that we haven't learned how to do yet. So I guess it's quite tricky for you. But I will show you the answer. I'll show you a worked solution to that and teach you a little bit about what I've done. Finally, I'd like to make sure that both the programs that you create are fully commented. In fact, I'd like to go so far as to say that every program that you write from now on is fully commented. You may not fully understand the reasons why comments are so important, but I'll tell you this. If you've ever developed a full-scale industrial program, say 100,000 lines of code, can you really honestly remember what every single line of code does in those 100,000 lines? What if the code is not written by you? What if you've just written 10,000 lines of those and 9 other programmers have written the other 90,000 lines? And you need to go and fix a bug or add a new feature in their piece of code. Maybe they've left the company and it's your responsibility to look after their code now. And you go into their code and it's not commented. Okay, I think you're getting the general idea. But I will say that I've written pieces of code myself, pieces of code that I thought were quite simple and straightforward and that I was very happy with. And 6 months later I go back and I look at the code and I go, why did I do that? What's that line doing? I don't understand why this is doing this, what it's doing. Now, I can obviously figure it out if I take a bit of time, but the point is I don't want to have to take time. I want a little comment sitting right there to say, this is why I've done this. This is why this is done now and not something else. That's what comments are about. Anyway, that's chapter 3 exercises. Come back and I'll show you the solutions in the next